So here let's do a problem using vectors and refreshing our memory on bearings. So a helicopter travels from base station S on a true bearing of 75 degrees, and true bearing, it means that the bearing is represented with 3 digits, and that's why here we have a 0. So it travels for 100 kilometers to outpost A. It then travels 150 kilometers on a true bearing 150 to outpost B. And we are supposed to find the distance from A to B and then the bearing of outpost B from station S. So here is the diagram of the problem. Vectors n1 and n2 represent not directions of unit 1. Both are equal, the lengths are equal 1, and 1 unit is here represents 25 kilometers. So here the bearing of vector u is 75, is gamma 75 degrees. Now then it is it changes the direction, the helicopter changes the direction, and it travels for 150 kilometers and the bearing is here 150 degrees. Now first let's notice that the bearing of the opposite direction, so here is the opposite direction, and the bearing of the opposite direction, so here u is 75 degrees is delta, and if we add here 180 degrees, we'll get the bearing of the opposite direction. So delta plus 180 degrees gives me the bearing of the opposite direction. That's why the bearing here is the bearing of point A, of point S from point A is 75 degrees plus 180, which is 255 degrees. Now if we want to calculate the angle between vector v and vector minus u, here we are taking the opposite of u, then we'll have to subtract this bearing epsilon and delta to get the value between the two vectors v and negative u, and the value then we'll get 105 degrees. Yes. So now we can plug in the values. Well, first let's derive the formula. Here's the formula. So the length of vector u of vector w, here I use the cosine law, and the we found that the cosine that the angle between the two angles is can be derived from this formula, which is gamma plus 180. So this is the bearing of the opposite to vector u direction, and then we subtract the bearing of delta, and we get the value between the vectors v and u2, which u2 is the opposite of u. And now plugging in the numbers to the calculator. Here it is 150 degrees and so on and so on. Calculating this value and then square rooting the answer, you'll get the value of length of length of vector w. And now, okay, we have to find the bearing of vector w. In order to do so, we need to find the angle B, S, A, and we have to add it to vector gamma to get the bearing of point B from point S. And here we can use sinus law. So the length of V divided by sinus of the angle that we are looking for equals to the length of W, which we already found. It is in the answer in our calculator, and divided by the length by this angle here, by the measure of this angle. So now applying the sinus law, so it is the length of vector W divided by sinus 105 degrees equals to the length of V divided by, and this is the angle we are looking for, and let's call it sinus of sinus x. And then after making sinus x the subject of the formula, you'll get sinus x equals to V, the length of V divided by the length of W times sinus of 105 degrees. Yes, and now then x then equals to the inverse of the value here, the inverse sinus of whatever is here, V divided by W, the length of W times sinus 105 degrees. Now to get the bearing of, because actually it's not what we are looking for, but we are looking for the bearing of point B, so we have to add, to get the bearing we have to add delta and x together to get the bearing of point B. So the bearing is then sinus of inverse sinus of the value plus delta, and this is the bearing of point B, the formula to find it, and of course I believe you can do it, you can find the numerical value by using the calculator.